Hello everyone. Setup changing today. So you guys are here, but I'm watching here. Changing today. And I forgot to. Okay, there you go. Can you guys hear me well? So we are in the lab. So actually the streaming room is on this side, and I'm on the lab, which is where we try a bunch of stuff. And why we're here today, because we have to talk about the nylon printing for like 20 minutes, half an hour, like we said last time. The goal would be to have like the first part of the stream talking about the topic, so which is printing nylon today, and then after that we'll go through the different questions that you guys have. And behind me, you can see these two printers. Can you hear me when I'm that far? Because I don't have the microphone. I'm using the internal microphone from the computer. But basically, these two are printing the nylon, already printing some parts. But what I thought we could do is to troubleshoot the print issue together to see. I will show you how I usually do. I can see already on my stringing test there is a few issues. So I'm going to stop the print. We're gonna check the print together. And then I'm going to change the setting on Cura, and then I'm going to start another one. And then it will take around maybe 20 minutes, 15 to 20 minutes, and then we're going to see the result. So hopefully we can solve the problem in one iteration. And on the other side, I already did one iteration, so that's the second one. And I'm printing our material scientist. So the goal being, I've seen a lot of people printing, like I used to print, a lot of gears with nylon, but I've seen a lot of people printing with a lot of overhang. So what I was thinking is, if I manage to have a profile to print that guy well, then I think most of the models should work with that profile. So let me quickly check the chat if you guys are hearing me okay. The video is okay. So we have Asian Jackbox of Awesome. How do you solve the issue with shrinking? So I will answer all the questions that are nylon related, so that we stay on the topic. So I did share. I shared a file. Actually, it was a lot of screenshots that I share on Twitter with all the shrinking rate. Actually, I can show you. It was something like this. Can I? Sorry, I cannot share my screen, but I can do something like this. So what you can see here is basically you can select all, like this is the cube. So this is a 40 millimeter cube, 60 millimeter cube, 80 millimeter cube, and then you can check after annealing or after moisture saturation, and then also what infill, and then it will show you what shrinkage rate you have. So I don't know if the quality is good enough for you to read the screen. I really need to have some kind of stuff that allows me to share the screen. Let me put back the camera. Actually, you guys are on the S1. We received that 2 weeks ago. So I wanted to see if the direct extruder could print the TPU a little bit better. But to answer the question, let's say after annealing for a cube that is 60 millimeter by 60 by 60 at 20% infill, copier would shrink by 0.1% on the XY and by 0.3% on the Z-axis. So I think not that much, depending on what accuracy you need for your print. Abdullah, thank you for joining again. Josia is here as well. Santiago, of course. Okay, let's scroll down a little bit. Yeah, by the way, I sent the shrinkage, the Excel file to Santiago. So if you have any question, maybe Santiago can help to share the data. He has the actual Excel where he can check all the data. And what I'm working on is a kind of a web page where you will have all our different materials, all the different properties, and then you will be able to select like all our PLA, you just select the different PLA, and then you select what you want to compare, like tensor strengths, impact strengths, etc. And then you will have graph in the middle that will be quite interactive, and then you will be able to see. So I already have this on Excel, but I need to make the web version now. Okay, so talking about Copier. So a lot of people were wanted to try to print with our nylon, but had a couple of issues. So I tried to replicate the issues. So the first one was bad surface quality and a lot of stringing. So how can I? Okay, like this. So you can see a lot of stringing, a lot of issues. So this is Copier, and then even the surface quality is not that good. You can see the top layer here. If it can zoom in the top layer, you see a lot of under extrusion, and then I think the mechanical property, yeah, not that good. You see the layer adhesion. I can break his head. If it would have been printed well with Copier, I think it would have been very difficult to tear the head apart. But it was pretty easy. So what I did is I tried to see if we could get a good quality out of nylon, even though it has absorbed moisture. Well, it was not good in terms of stringing. So it's a little bit better. So this is the same spool. So what produced this and this was the same spool. But you can notice that the surface quality on this one is much, much better. But the stringing is not. I mean, it's slightly, like much better, but still, I mean, we are far from having something that that you don't have to clean up, right? If I put it this way. But the surface quality is much better. Even the first layer, the top layer. So what I did from this one to this one. So again, we are talking about a spool that has absorbed a lot of moisture. So the trick I use is I print it at a very low temperature, which is really not good for mechanical properties. I'm pretty sure I can break this one even easier. Yeah, you see, I can break the head, and then actually it's coming apart pretty easily. Yeah, you see, even it delaminates the big layer at the base. So the idea here is I wanted to check if by lowering the temperature, then you can solve the the moisture issue. And even if I think I printed this one at 240 degree or 235, and so it even at that temperature it didn't solve the stringing issue. So the moisture for Copier is pretty serious. So what I did is I dried the two spools. So can I? Oh, okay, let's do vlog version. Can you guys see like a good quality, or if I keep shaking like this with my hand, then it will start maybe to be a bit blurry. But let me know. I will try to keep up with the with the chat. If it's too blurry, just let me know in the chat. Then I will try to find a steady position. So you can see my first spool over there behind. You have the polybox there, and then so I first dry in our oven. So you can see I dry it at 80 degree. So you cannot see on the camera, but here is 80 degree. And then I put the spool inside. And then after I dried, so for that one, I dried for the night. So let's say around 12 hours. Like I put it yesterday, and then I came back this morning, and then I put it on the printer. So around 12 hours. And then you can see the polybox there that is feeding this printer. And this printer is the one that is printing the material scientist. So you can see here, it looks like it's going to be pretty successful. I mean, we have very good and consistent layers. But let's see how it goes. And I'm printing this at 260 degrees, which is not recommended on the Ender 3, because if you are, if you're printing at 260 for too long, then I think it's gonna damage the print head pretty quickly. but that's just for testing purpose. I'm pretty sure most of you has modified and put a all metal hot end. But otherwise, you could print at 250. You will have a slightly lower layer adhesion. It's still not bad if it's very dry, but 260 is more recommended. And then here, you have the one that is printing the stringing test, which I'm going to take right now because I need to put the new G code, and then we can analyze how the stringing test went, because that's the main problem that you guys have is the stringing. So we have Loyal Moses is here. So how many of you have joined yesterday's stream? I was actually invited on the LM show, and we had a lot of fun talking about material science. So I was so happy to share what we're talking every week here, but to much more people. I think we were around like 50 people, I think, talking about material science. That was just awesome. So let me stop that print, and then we are going to check. So that's the stringing test, and then we are going to check together the result and see what we could improve. So the bed is not hot because with our nylon you don't print, you don't need a heated bed. So well, it's a little bit warm. Oh, I put it at 35 degrees, so it's a little bit warm. But I've seen a question talking about what print bed I'm using. So this is the stock from Ender. So it's a piece of glass with a kind of texture on top. Yeah, sorry, it's not very clean, but usually that helps more than anything. So we can see the stringing test here. So you can see it's not perfect. Well, it's way better than what I've seen on Twitter. So that could already be good enough for some people. Let me try to let me remove it, and then let's try to check it closer. So it's not, you see, it's not hard to remove. You just go, you just scrub it up, and then you can see. So one of them is pretty nice, and then you have this oozing issue. You have a little bit of stringing, a tiny bit of stringing. Yeah, I don't know how to show that, but yeah, here you have a tiny bit of stringing, but a lot of oozing issue. And if you remember the stream we did, and we talked about what is stringing, where does that come from, what is oozing, what's the difference between stringing and oozing. So now I can see that the stringing is quite okay. It could be improved, right? Even though this is very easy to clean. You just take a lighter, and then all of these like spider webs will just disappear. But it looks like the biggest artifact of this print is the oozing issue. You can see it's oozing because you have that kind of like thingy that is building up, and it's basically every time the nozzle is going to come back to this island, from this island, the printing island, to this printing island, it will always kind of have a residue, and it will be wiped off by this kind of curved tower. And every time it will come, then it will wipe off here. So this is what I call oozing. So it's pretty easy to solve that. I will jump on Cura, open my setting. Again, I cannot share my screen. I wish I could. And then I will just type wiping. So I will do a small wipe. So let's go to wipe, and then I will share that Cura project. I will share it on our website so that you guys can just download, and then you don't need to go through all the trouble of testing. But again, it's all about drying the filament. 80 degrees for 12 hours. This is what I did. I think 80 degrees for 8 hours should also be fine. But yeah, you better just dry it overnight, and then that's it. so wiping distance, what I'm going to add is I'm going to add 0.1 millimeter. So that will force the printer to wipe the print head. Why I don't put much? Because in Cura they already have a wiping process when they go from one island to the other island. So I'm just going to force a little bit more that wiping process. So what they do on Cura is when they finish a layer, they go back a little bit towards the center of the island you're printing, and then they go to the other island. So that's doing the wipe. But again, remember that the wiping process is only for stringing. It doesn't solve the oozing issue. It only solves the stringing issue. So the stringing is because the polymer will stick to the polymer inside the nozzle, and then it will create that string, right? So if you wipe the nozzle, then you're cutting that string. And here we don't have a stringing issue. We have an oozing issue. We have a little bit of string. That's why I don't put a big wipe, because we don't have much stringing issue. And the wiping may also enhance a little bit, like overheat the other layer. So I don't want to do it too much. So that's the reason. Now we are going to talk about the oozing. So oozing, I'm going to jump on casting. I'm going to enable casting. It's very funny because on Cura, it's still an experimental feature, which, yeah, I don't know why they call this experimental. I think a lot of people are very familiar with this one. I think it should be a default feature now. Yeah, so I'm going to enable casting. I also don't like the fact that Cura, they are putting casting as a millimeter cube. So usually I do that on Simplify 3D, and it's like the distance that the nozzle is going to continue is the distance. So casting is the distance that at which the nozzle will stop extruding before reaching the end of the layer. So let's say you have a layer that go all around, then you will go all around, and if you have 1 millimeter casting, then 1 millimeter before arriving to the end point, it will stop extruding. So why this is good is because instead of oozing the rest of the residual pressure on the nozzle outside of the model, then you will use that residual pressure to finish the layer. So that's why we call this casting, basically. So why I don't like this millimeter cube is because I have no idea. What I would like is, when I see this, then I'm pretty sure I could use that extra blob here to fill up maybe 0.1, 0.2 millimeter of my layer instead of being here. But I don't know how it translates into millimeter cube. And then I would need to calculate, etc. So what I'm going to do is I will just leave it like this. They suggest 0.064 millimeter cube. So hopefully that's what I need. I have no idea. But I'm just gonna test. So I will save this this new setting. I'm not gonna change anything else. I don't think there is other stuff. I mean, another way to solve that problem is to lower the temperature, but that's what we don't want to do because we don't want to affect the layer adhesion. So what I'm gonna do now is I'm going to put it on the micro SD card, and then we are going to start this new print and see if we solve our problem. It should be fine. I think it should reduce. Another thing is, I don't know if you noticed, but I didn't put the second copier on the polybox in the polybox. The main reason is I want to know how fast it can absorb moisture and affect the print. So it's not good to do that at the same time as you're trying to solve the issue. But let's make the hypothesis that in this room, I put the aircon, it's like around 29 degrees C in this room. So it shouldn't be a big problem. So I'm now putting this here, and then I will start the print again. Maybe with a bed. And then let's see how it goes. The good thing with copier is you don't have to wait like ABS or ASA that the bed heat up. because you basically don't need the heated bed. Okay, let's see how it goes. And then I'm gonna check quickly the other one. Yeah, it's printing pretty nice. I think we will have a lot of luck with the other one. So they are both using the same G code. So the same setting. So most likely this one will also have this issue. Let me check. We'll also have a little bit of this issue, but that's much better than this, right? Much better than this one. So if we solve this problem with the new setting we have here, then we just implement that into this one, and then re-export the G code, and then we will have our perfect material scientist. So this is basically our bench sheet. You see, there's you can play around with this one. It's a pretty nice model. You have a big overhang here. You have thin wall. You have bridging. You have a nice overhang here with a curve. You have the chin here that is hard to print. You have the tip of the hair that you need to manage the cooling as well. You have a lot of islands for the molecule at the back. So that's also a lot of island means a lot of retraction setting that you need to figure out. So this is quite a nice model to play with. And then you also have the two legs. And if it's curling a little bit, then you will break the leg. So if you manage to print this well, then most likely you have a pretty good profile. Okay, so we are going to wait for maybe, let's say 15 minutes. And during that 15 minutes, let me try to see if there is any question on the chat. So I will go from the end. So non-fam, hi, thank you for joining again. Copier stringing are a pain to remove. I had a wet part, just make a permanent bond. Yeah, I mean, pretty much any material, if they absorb moisture, then you will have stringing issues. Okay, let me check. Will there be a polycarbonate family? Blah, blah, blah. So we will answer the other question after. If you guys, there's too many things. So if you guys have any question related to nylon, please put it now, and then we will use this. We will use this 15 minutes just to wait our new print and see if I can answer some of them, and then I will also reduce the aircon. We start to be pretty hot around here. So in terms of the other setting, I'm using, let me check what. So I'm using generic nylon, the standard nylon profile on Cura as a base. And then from that, let me check if I can see easily the what I changed. Okay, so what I changed. The first one is I'm printing with a higher layer height. I'm printing at 0.25. So all of these guys that you have seen, they are printing at 0.25 layer height. Why I do that is usually our materials, somehow you don't really see the layer height, the layers. And when I'm printing at 0.25, then it looks like I'm printing at 0.2. So the good thing is I'm adding that extra strength, because the thicker the layer, the stronger, but without compromising on the quality. So that's the first thing I change from that generic, the generic profile. The second one is the build plate. The build plate is at 40 degrees C. Well, I don't know why it was 35 here, but it's 40 degrees C. I think the generic profile is at 70 or 80, but if you put above 50 with our polyamide family, like all the nylon material, then you will have a big warping issue. because of the warp-free technology that we talked last time, the crystallization rate. Oh yeah, one thing, I remove combing. I don't know why it's on by default. I really don't like this this feature. So combing is basically avoiding the model every time, and one thing I really don't want is to increase the path length of the nozzle. So I always remove combing mode. If I would have combing, then these models would be even worse. Build plate adhesion. I'm using a brim. I hate raft. Why I hate raft is because I can never either I have the perfect setting, and then I can remove the raft easily, but then I have a very rough surface, or I have a nice surface, but then it's very hard to remove the raft. Well, anyway, overall, I hate raft, and I always use brim. Why raft exists, in my opinion, is I think before we couldn't ensure that the bed was always leveled, and then we always use a raft because the raft have a very thick base, and this thick base was compensating the bed unleveling. But I think right now we're pretty good at leveling beds, and I think machines are now have tools that allow us to level the bed easier. So we don't need raft anymore, in my opinion. So I always use a brim. Why a brim? Because I want to extend the surface area of my first layer so that it stick well to the bed. And that's basically it. Except from the one I just said. So this is for the global setting. For the other setting, I always like to print with more shells. So for this one, I print with 4 shells. Why I like more shells is because you have better overhang, because basically the overhang will use the inner shell in order to support itself. So if you have more shell, then it will improve the quality. Also, if you have very steep, not steep, but like a very small angle, like if you're printing the shoes will go like this, right? And in this one, you're going to see the layers because the slope is very high or low, depending on where you put it. But what I like is to increase the number of shells so that the steps are higher quality. Otherwise, you will have 2 shells, and then you will start to see the top layer, and then you will have 2 shells and see the top layer. But if you have more shells, then it allows you to have a higher quality step. So this is particularly true for the shoes. What else? The wiping, the costing, we did that together. Yeah, I don't like to fill the gaps between prints. If you're looking for high quality prints, not much strong print, even though it wouldn't help too much, but I would also remove that setting. I don't know why it's by default, but usually that extra flow that you will have to drop in between the walls to fill in the gap will mess up the print, because printers are not that good at flow management. Well, I mean, it depends. Some of them, yes, but most of them, no. So that extra effort that you're asking the printer to do will have some small artifact on your print. So if you are a big fan of perfect print, then I would remove it. I really like to end up with like the perfect print, like no seam. Like you ask someone, how I printed it, and then they kind of struggle to see where it started, etc. So I would remove that one. Print the thin wall, yeah, that depending on the model. Top and bottom layer, I usually use 6. So I use 6 with polycarbonates, nylon, all the materials that don't use 100% fan. I use 6 top layer, which is more than usual. Usually I use 3 or 4. The main reason is these materials are pretty bad at bridging because there's no fan. So you need more layers in order to sorry. Looks like I didn't have a very good first layer. Let me try to start again. Yeah, that's why usually I don't like to remove the bed. I try to remove the print from the bed because you see I removed the bed in order to show you, and then I put it back, and most likely I messed up my my leveling. So it ended up with this first layer. So what I'm going to do now is I will turn all the knob in order to raise up the platform. Don't do that if you are not used to play with the knob. Just use the nozzle and then put the paper like the old-fashioned way. But after you use the printer a lot, you know exactly, when you see, I'll show you the fail print. When you look at the fail print, you basically know exactly how much to turn. Once you know that, then you don't have to do that whole trouble again. So infield density, I use 10%. You can see here. Infill pattern, I use triangle. I love triangle. Why? Because if you make a rough guess on the probability of having the shortest bridging effort for the printer for the lowest infill, then the triangle would be the best. And that's just a guess. I didn't make the equation, but I'm pretty sure if you make the equation, that should be the lowest effort for the printer to bridge over. That's actually the reason why, not exactly the reason, but a similar reason why you break down things into triangles, right? You break down the 3D models into triangles. Printing temperature 260, the flow I leave it at 100%. Print speed 55 millimeter per second. Travel speed I bump up to 300. You remember during our stream when we talked about oozing and stringing that time is a big factor. So I shrink down that time to the minimum by increasing the maximum travel speed, which is 300 millimeter per second for the Ender 3. It doesn't help so much for this one because it doesn't have time to reach that speed. But yeah, when it can, then it will be able to go to 300. Retraction distance, I put 4 millimeter, and the retraction speed, I put 45, which is a little bit higher than usual. The fan speed, I put a gradient between 0 and 20, depending on what it's printing. The brim is 10 line, and then I enable costing, but this is the thing we did together. Okay, did it start again? Nope, not yet. So let's have a look at the other one. Okay, so the other one is arriving to the legs. So we will soon be able to see normally the same as this one. And like I said, if you end up with this quality, this is PLA, this is Polymax PLA. This quality with Polymide Copier with a little bit of oozing like this, then I think it's already pretty good. And what we're gonna do is just solving this, and that's why we do the test there. So now it's starting the first layer. Let me quickly check. Okay, it looks okay, but as I won't be able to see the whole first layer, I'm going to squish a little bit more the first layer. And then I'm rubbing my finger on the first layer to see if it's if it would unstick, but it didn't. So we are pretty much good to go. Collie, one of the reasons I installed clippers was so I could baby step my Z level. Yeah, good idea. Does Pablo, do you use a Prusa printer? No, I do not have Prusa printer here. So here I have, let me bring you. So I have two Ultimaker 2 Extended Plus. I have the MakerBot. Then I have 3 and the 3. This is all the V2, and then I have V1 of on in the office, and then this is the S1, and then I have the oven here. So this is the one I have in the lab here, but I don't have Prusa. We have Prusa in the Europe office. Abdullah Spaghetti, yeah, that's the reason why we should always check the first layer. Depending on design, I usually boil my part for a short after annealing to condition it. Yeah, so that's a good point. You can, to make the parts a bit stronger, or sorry, I should say a bit tougher. Then you can moisture condition it. So you can boil it in water for like maybe 10 to 15 minutes, and that's actually a good point. Copier is pretty bad at overhang, right? Or you have to use the fan. But we usually use a lot of support. And the good thing is, if you use Polydissolve S1, so the PVA, if you use PVA for nylon, then dissolving the PVA is very, very easy, because you can just put the part in boiling water, then the PVA will just disappear, because boiling water means hot, means a lot of flow, so a lot of convection. So that's the two things that decrease the dissolution time. So boiling water is perfect to dissolve PVA, but the problem is you cannot do that with PLA or even PETG, but nylon you can. So you can just use PVA and just throw it in boiling water, and then it will dissolve in no time. What does mixing PA6 and PA12 do? Also nylon 5-6 plastic. Well, if you blend PA6 and PA12, then you have a PA6 PA12 blend, I guess. But it will eventually absorb humidity from air anyway. Try annealing, blah, blah, blah. I would say depend on where the part will be used, since copier becomes less stiff in a wet state. Yeah, so if you compare the wet state and the dry state in our TDS, you will see a big difference. And usually the difference will be the modulus will go down, and then the impact resistance will go up. So you will toughen up the material by conditioning in water. How much is an Ender 3 in China? So we bought this one, I think around 1,000 yuan. So let me check. CNY USD. So 1,000 yuan is 157 USD. So around 150 USD. Well, even though we had a special price after for this one, because we buy because we are a Creality partner as well, so we can get a bunch of them for a bit cheaper to test the materials. You should try designing your own 3D printer for high speed. Blah, blah. Are you talking to me or to Santiago? I think Santiago has more knowledge to design a printer. Pure PA12 filament that prints like copier. Yeah, PA12 is very hard to print on itself without our warp-free technology and without a Garolite bed. I saw someone asking on Twitter what bed to take for nylon. So you can print nylon on any printer, on any bed surface, more or less, except PA12. PA12 somehow doesn't stick into anything except Garolite. We talked about this yesterday during the LM show. Okay, so I think we are reaching the. Oh, you know what? Actually, that print is way better than the stringing test. You know what? What I think, my hypothesis, is that this is a torture test, right? I mean, you are pushing the printer not to the limit, but close to the limit because the cylinder are very small. So I think that's why you have a little bit of stringing. But that one, let me check again. Yeah, that one has literally pretty much no stringing issue. Let me try to show you. Can you see anything? It's just perfect. I mean, even, let me check the overhang. Even the overhang is perfect. Everything is perfect. It does has a tiny bit of stringing issue, but like a tiny bit, like a tiny spider web. And I think we can get rid of this with a tiny bit of costing. Wiping. And you see the shoes are very high quality because of the 4 shells. And I think the overhang is also quite high quality because of the 4 shells. So I think, let me check again the top layer. Yeah, I think we got the perfect profile now. I will still need to confirm by printing with these additional costing, wiping. But let me put it down a little bit. So can you stay up? Yeah, sorry, I don't have the. This is the webcam I'm using. So yeah, I'm pretty sure we have a pretty good profile there. I think we're gonna have. My guess is it will be a tiny bit better than this one, because the surface quality of nylon is a bit better. I mean, it's like a very shiny one, so you can see the quality very. So if it's very shiny, you will see all the imperfection very well. So if you have a shiny print that doesn't have any imperfection, then it looks much better than this kind of print that is a little bit matte print. Yeah, so I'm pretty happy that we formulate a perfect profile together. I need a Polymaker t-shirt. Yeah, actually, Loyal. That's the only one in the world. I have a black version and I have a white version, but I'm thinking of making some Polymaker merchandise. I think it's pretty cool. I want to send that to you guys. I want you to become a material scientist. Maybe I should have some kind of Polymaker here, and then I will put like some kind of like a material scientist somewhere. Then you guys can be proud of all of this knowledge, and you guys can share the knowledge around. So Josiah, minimum layer time would vary depending on wall thickness, printing temperature. Yes. Oh, it's great to have Santiago in the chat. He can answer all the question in good detail. Loyal, yes, I'd love to wear it on the stream. Yeah, definitely. Let me try to make some. Maybe I will make maybe 10 or 20 of special one. I don't know if I will have this design because this is for the weekly stream. Let's talk about 3D printing and then Polymaker Live. But I can make another one like, you can give me some ideas on, I love 3D printing, or like material is the future, something like this. I need to think about a great thing to write with material scientists or something like this. Or I'm a material expert or something. I mean, I'm not a material expert, but we can create our group of material experts. Bang enter to win our Polymaker. Yeah, I have no idea how to do that, but I want to start giving away also some spools during the stream, but I don't know. I have to investigate how to use YouTube in order to do that. I talked with Loyal. Apparently, there's a big community on Discord as well, so I need to investigate whether it would be good to enter Discord, and maybe we can have even more people to share with. Right now, you can go on the LM show. I think Loyal is giving away a lot of stuff. So if you want to try some prints, you can go there. And also, I still need to talk with Loyal because he talked about a special sponsorship for the LM show. I don't know if I could send 10 spool per week just to give away so that even more people could try 3D printing. But I would have to talk with talk with him. Oh yeah, the sparkle filament. So I think I stayed a little bit on the stream with Loyal yesterday. So we do have a sparkle filament left. Not a lot. I think around 100 spool of blue. The green, I need to check. Maybe we already run out of green. But maybe what I can do is I will either put that on the website and then I will allow only people with a certain code to get them. And then I will just share the code here, or I will send some to Loyal. I will send like 20 spool, and then you can just get it for free for a giveaway on the LM show. But we can check what to do with the last stock because unfortunately it was too expensive to produce, and if we put it at the price that makes sense for us, nobody buy. So now we just put it at a very low price just to get rid of the stock. And then we are going to launch we launched already our Galaxy series, which is a more cost-effective version of the Sparkle. Collie, the t-shirt could say Polymaker Live, turning everyone into armchair material scientists. Yeah, pretty good. You can send your ideas. I can also have, we are in China, so producing this kind of thing is very efficient. You just send the design and then they send you, like in 2 days, they send you the finished t-shirt. And so we could do like a special one, for example, for Loyal, we can have the LM show and Polymaker. And then for you guys, we could have your name directly printing on it. So there's a lot of possibilities. We bought all the sparkle dark green last night during our stream of Amazon. Yeah, actually, I've seen that. I checked our Amazon and somehow yesterday a lot of sparkle went away. So I'm pretty sure I knew where it come from. I have 1 blue and 2 green coming. Hi, Maker My Right. How are you doing? Yeah, good. Like I said, the green, I'm not too sure how much we have left, but we do have around 100 blue left. So that should be fine. What filament extruder do Polymaker use? Filament extruder? You mean the extruder of the printer? Well, they are all stock extruder. I mean, the hot end is stock and the extruder is stock. We don't do any modification. There's 2 main reasons. The first reason is we want to have printer that most of people has. I don't think a lot of people, I mean, in the community, maybe you have 20 to 30% of people that modify, not in the community, in all the people in the world that has a printer, let's say this way, I would guess less than 5%, 10 or 5% modify their printer. I don't think a lot of them receive the printer and start to tweak around and then change the extruder, put a E3D hot end and then change to a flexible plate, this kind of thing. I think a very few people does that. So that's why we want to keep the stock printer. The second reason is sometimes we don't have time. We would love to play more with printers, but we are like a print farm. We are printing to create our content, and we don't spend a lot of time tweaking the printer. I used to do that when I was a printing engineer here at Polymaker. I used to have a bed in the print lab where I was sleeping, and then I had just my printer around. And what I always say to people is, if you want to be a printing expert, or if you want to learn a lot about printer, well, I give you the best tip. You print a Banshee, and then you watch the whole print. Not only the first layer, you just stay in front of the printer for the whole print, from the start to the finish. And I can promise you, by doing that, like just checking, not going on your phone, not watching a movie, just watching this print during 2 or 3 hours. Don't do the speed run of printing Banshee, right? and then you just check. You just stay there and check. I did that multiple times. Even this one, I pretty much watched the whole print. Why? Because that's the best way. You have to check what's going on, and then how it prints, and then you learn a ton. You learn a ton by just doing that. The only chain we deal with are polymer chain. Yeah, that's pretty good. Extruder to make filament, I mean. Oh, okay. Well, I cannot say, even though I think if I send the brand of our extruder, I think you wouldn't know. But unfortunately, that's a sensitive information on the equipment we use to extrude our filament. Best pun so far. I feel you, Nick. There is just no time to mess with setting on a farm. Always have a spare to play with. I watch all my printers. You learn the thickness from eye. I do understand the second one, but yeah, definitely. Print farm, you don't want to, yeah, you want the printer to work. You have a printer on the side to play around and then to tweak the setting, and you want to put that on the print farm, and then everything prints properly. I mean, can you imagine a guy that has 50 printer, for example, and then he needs to watch the first layer every time there is a new print? And let's say he's printing gears, like take 5 hours to print. Then I mean, every 5 hours, 50. I mean, that's impossible, right? We need to have reliable. Oh, by the way, let me show you something pretty cool. Check out this. How cool is that? This is transparent TPU, and it's like a handbag. How cool is that? And there's some kind of texture. Transparent TPU, and the string is the TPU we used. Yeah, I saw that on my desk when I arrived. So they just printed that, and I thought it was because we are testing the TPU on the S1, and I thought it was so cool. I mean, I didn't see a lot of transparent TPU print in the office. We always have polysmooth transparent print. So I mean, it's not as transparent as polysmooth, but I mean, it's not bad. And then if you have a bunch of stuff inside, then you kind of see a little bit. I mean, it's quite transparent, actually. You can see my hand, right? Even my ring. So yeah, what do you guys think? I thought it was pretty cool. I agree. I have sat for hours watching every single layers. Yeah, that's the best. Actually, you know, CNC Kitchen, Stefan from CNC Kitchen on YouTube, he made a very long video, and then he put a camera straight on the nozzle, and then you could see it printing. I promise you, I watched the whole video. I was just like this, just like I watch a movie. You know, it could be boring for some people, but I don't know, you learn so much by just watching it printing, and then sometimes it just print that thick layer that is very consistent, and that's so satisfying. And then sometimes you have somehow a small defect, and that's like the part of the movie that is a little bit stressful when you have like these artifacts. Well, anyway, maybe I'm a little bit crazy, but it looks like in the community, a lot of us are a little bit crazy about 3D printing, so I feel okay. I surprisingly H-bent. Sorry, Josiah, I don't understand. Me too is hypnotizing. Yeah, definitely. I mean, I'm pretty sure most of you guys have done that. Have watched at least half an hour of the print, and then realizing that you just spent half an hour watching the printer going around like this. I miss printing my clear TPU. Oh, you also have clear GPU. Yeah, I mean, it's pretty nice. It's pretty cool. I like it. It seems to have some ringing. Yeah, I think so. Let me check. Well, oh yeah, a little bit. But I don't think you can see that on camera. I think what you're talking about is the layer inconsistency, no? Because the ringing, I mean, it's pretty hard to see. I don't think you can catch that on camera, but there is a tiny bit. Yeah, ghosting, ringing. That's also another interesting topic. Maybe in the next stream we can talk about what is behind ringing and stringing and how to solve that. It's pretty straightforward. I'm pretty sure you guys know, but we can talk about that topic as well. Oh, we forgot our prints. Let me check. Yeah, so to be honest, the material scientist is perfect. I'm wondering, I will still try to add costing, a little bit of costing, and then try again. But I think this profile is close to perfect. Let me check the stringing test. Yeah, so that's what I was afraid of. The costing is too much. I can see some tiny holes on every layers. So that means it stopped extruding, and then it doesn't have enough residual pressure. So my hypothesis here is the costing is not going to help, because the oozing that you are seeing is not from residual pressure. The oozing you are seeing is from, do you remember, time, residual pressure, gravity, and friction of the nozzle. So if I analyze what's happening here, the costing is not helping, which remove the residual pressure factor. So the oozing we are having here is not because of residual pressure, it's because of gravity. So gravity, how to solve the gravity problem? So you have to change planet. No, I'm joking. So you have to increase the friction in the nozzle. And to do that, you either have to lower the temperature, either have to change the nozzle. You need a nozzle with a longer die. So I think we cannot improve the profile itself. I think the profile is pretty good, especially when I check the other one. So in order to improve the print itself, you could change the nozzle, have a nozzle with a longer die. You could print on the printer that can go faster in terms of travel speed. Or let me think. We could try to tweak the retraction a little bit, but I don't think it's going to help so much. But yeah, I think that's pretty much it. Because let me show you. Let me show you why the costing was not a good idea. I will stop the print and then I will show you. So if we compare, so it's pretty much the same. We haven't solved anything. Maybe a tiny bit better, but not much. So I mean, right now we are really playing on making the profile like perfect, because I'm seeing the other one. I will post some high quality picture on Twitter as soon as it's finished. But now we are really we are really a little bit picky on the printer, and I don't think if you can catch that on camera, but there is some tiny holes. Yeah, I don't think you can. But you get what I mean. If the costing is too high, then you have some tiny holes, and actually, yeah. So yeah, I think that one will prove that our profile is pretty good, is pretty much good to go. Okay, so what I'm gonna do is I will take a picture of this one once it's finished, most likely in 1 hour, and then I will post it on Twitter. So blah blah blah. Some more people came in, right? Oh, comic edge clothing. I think it's from the LM show also, right? I know what you mean. It's almost hypnotized. Yeah, definitely. I wish I had time to see an entire print. Yeah, we always have time. Just don't sleep. If hour, more like half a day. Hi guys, good to see you all here. Sorry I'm late. No worries. Comic Edge Clothing. I will call you Comic. That's gonna be a bit easier for me. Nick was so good. It was so good to watch you on the LM show. Yeah, it was nice, and I hope we can do that again. I mean, the community that Loyal is building is I really like it. I really like it, and I will fully support. I can take advantage of the fact that I'm working here at Polymaker to help supporting as much as I can the community building. Nick, we will have to get you a better chair. Yeah, you know what? I already broke 2 chairs here. I mean, I'm pretty big. I mean, I'm 2 meters tall. Wow. I don't know. You guys don't know what is meter, right? Meter. What do you guys use? Feet, right? Let me check. How many feet is 2 meters? Because last time I went to the US, I said I'm 2 meters. Nobody understands. 6.56 feet. So, and then I'm 120 kg, 125, and again, you guys don't understand the kg, right? 125, and I'm 275 pounds. So 5.56 feet and 275 pounds. So I cannot sit on any chair. Well, at least, you know, in China, the standard size are kind of half of my size. So that's why I cannot sit on any chair. So this one is a pretty sturdy one. That's why I like it. It's not the most comfortable, but at least it can hold my weight. Me, every time I print, okay, I'm watching one more layer and I'm out. Yeah, that's exactly this, Abdullah. The same thing. I'm just here and I check just the first layer or maybe the first 3 layers to make sure. And then, oh, that overhang looks interesting. And then just check. And then finally it's the end of the print. Retraction. Yeah, we could try retraction to help with that. I will try. It could help. I'm already 4 millimeter and I'm already at 45 millimeter per second. So maybe going to 5 millimeter distance, 6 millimeter could help. I would have to try. Mars will bring a lot of new challenges for sure. Yeah, changing gravity will change one factor for a printer. Lol, go print on another planet. So I have to design camera mounts for those printers. Yeah, and if you can try Maker, Millwright, if you can try to have, you know, that camera that you can put straight on the print head, and then you can see exactly, you know, a macroscopic shot of what is printing. I love those one. Closing, blah blah blah. Tamapa mo prisa. Oh, that's Russian, no? I don't know how to read Russian. I think it's Russian alphabet. Make a mirror. That's so mean. What did you do to get the tiny chair? No, I didn't do anything. That's the standard one. You know, the one with the wheels. And then I broke 2 of them. I just laid down a little bit and then I just broke it. Print a new chair using copier. Well, you know what? I printed this. To sit next to the printer. Because when you watch, then sometimes you like to sit down. And I printed this in PLA Pro. There's no bottom layer. And I can sit on that. I mean, sometimes it crack a little bit in the middle, but no problem. This is PLA Pro. I can even stand on it. Well, I hope so. Yeah, I can stand on it, no problem. I mean, I think the marketing team last time told me to stand on a box made of PLA Pro just to show that it was strong. I don't know if I should take that well or not. But anyway, that's a good idea to print your own chair. Print a new chair using Copier or P12CF, yeah, or Polymax PC. They are bought. Oh, you mean the Tamara stuff? Something? Okay. Polymaker, I'll DM on you on Twitter so we can talk. Yeah, sure. Like a half seat, the Pro. That's so cool. Yeah, definitely. So, guys, it's been 1 hour 6 minutes now that we talked about our Copier. I think it was a lot of fun again. I'm not like a loyal. I cannot do a 4-hour stream. I don't know how he does that, but even that's why, when he invited me, the first question I asked him was, "Hey, loyal, how long do you think we are going to have the discussion?" So actually, because it's Chinese New Year here in China, so this week basically China is shut down. There's nothing open. But I love to come here and talk about 3D printing with you guys. So I'm printing PETG with a 1mm nozzle, LED of changing build plate to an IKEA mirror, a lot of playing around with temperature. Yeah, actually, if you print PETG with like transparent PETG with very thick layer, then the light diffusion would be awesome. We printed, it was a palette printer. Oh, I know you guys want to talk about palette printing as well, but it was a palette printer with a screw extruder, and then we printed that huge stuff with PETG with I'm talking about thick layers, right? And then the light diffusion was so awesome. Lol, you are the test weight. Yeah, definitely. I think if they want to see if something is strong, they just ask me to stand on it. Loyal, we could talk forever. Yeah, definitely. I mean, you know why? The reason I'm gonna stop the stream now at 1 hour 7 is because otherwise my wife is not gonna be happy that I'm spending my holiday time in the office talking about 3D printing. I always talk about 3D printing. At some point, she's giving me boundaries on when is the time I can even mention 3D printing. I can't wait for the translucent color line. Yeah, definitely. We are going to launch the PETG translucent colors. I really want people to get Polymaker in their hand. Yeah, I will try to give you even more so that you can give away more spool, so that people can try. I think if they try once, if they are introduced to 3D printing in a good way, I'm not saying our filament is the best, but if I can make sure, I know that if they use our filament, there is a high probability they will have a good experience. And I want people to have a good experience with 3D printing. Happy wife, important. Yeah, definitely. Okay, guys, thank you very much for joining again our weekly stream. Remember, next week, I will try to do a Europe-friendly time. So it will be on Saturday night for me. It should be Saturday morning for you and Saturday afternoon for Europe. So please remember this for next week. So thank you very much again. I will wait that this one finish, and then I will take some picture. I will post it on Twitter so you guys can see, and then I will share the profile on our website, and then I will share the link on our social media. So thank you again for everyone for coming, and then I will see you guys next week.
Hey, I see you just now.
What?
Just finished, right, baby, when I sent you a message.